In this video, we are going to tackle VLAN Trunking Protocol, or VTP. Now, VTP, if you've never heard of it or don't know much about it, you're in luck. VLAN Trunking Protocol is what it's called, but it should have been called a VLAN Replication Protocol, because that's actually what it does, is it replicates VLAN information. It replicates VLAN information between the switches, and it is Cisco proprietary. I don't know of any other vendor that supports VTP. I've only seen it on Cisco switches. Now, its goal is when you create a switch, or I'm sorry, a VLAN, and we pull up our topology here. When you create a VLAN on switch 1 here, what will end up happening is any other switches that are in the same Vtp domain, which we'll talk about here momentarily, that information will come across and be propagated to any other switch that's going to be willing to accept it. Now, the way this works out from configuration-wise, and the operational modes you need to be worried about, there's 3 of them. You're going to have server, you're going to have client, and you're going to have transparent. Now, server is every switch by default is in server mode. Server allows you to add, edit, or delete a VLAN or VLAN information, whether it's the name, the port that it belongs to, things like that. Now, the way that this is actually going to work out is, let me switch over to the pencil, because I think that just works a little nicer. The way this will actually work out is that when you're dealing with server, because every switch starts out as a server, there's not a whole lot to it. The first thing you'll do when you're starting to configure VTP is you're going to set up a Vtp domain. And what will end up happening is the first domain name that is learned or heard from in a VTP update that's received will automatically be inherited. The next thing you're going to take a look at is going to be you're going to want to configure a Vtp password. We'll take a look at doing that, and a couple little secrets into how to get those guys configured. And then once we have that in play, we're pretty much good to go. Then it's a matter of choosing which switch will have which role. Now, server, like I've mentioned already, is the default configuration for all Cisco switches. Now, that allows you to add, delete, and edit VLAN information on a regardless of what you're doing. Why is that not working? So you have that capability. A client does not have that ability. A client can only receive what another device sent it. So if you are a client, the only thing you can do is receive an update from a switch, or from a VTP update from a switch. Now, the way this typically works out is, let me grab my pen pad real quick, see if that's any easier to write with. The way this typically works out is whenever you receive an update, you're going to have what they refer to as a revision number. The rev is going to be an indication of things that are going on inside the network. Now, if you make it, if you edit a VLAN, if you delete a VLAN, you add a VLAN, every one of those changes is going to indicate a revision number change. So the way this will actually work out is if you make a change here, say you add a VLAN. So you add the VLAN, and your rev goes to 1. That's your rev number. Then you go in here and you've added it, and then you name it. So you name it, that's rev, becomes rev 2. The rev will indicate the most up-to-date VTP database. Now, this could be bad, and this is why a lot of companies don't like running VTP in that perspective, because you can actually take a new switch out of the box. You know, it may be new to you and out of the box new to you, but it may have been inside of an existing network, or I have seen people take a switch that wasn't in a lab, and in a pinch they needed more port density, and they just took it from the lab and they popped it into the network, to a production network. I actually had this problem happen about a month and a half ago. Customer calls me up in a panic from his cell phone because his phones didn't work, and he's like, I don't know what I did, but the network is broken. I'm like, what do you mean the network's broken? So I jump into our network monitoring system, and I'm looking at it like, oh yeah, you guys are broke, like really bad. The only thing I had access to was their edge router. And I normally had access into servers, and next thing you know, I've got the help desk calling me because we manage their network, but they do probably 10-15% work, and we handle everything else. So they do a lot of the day-to-day stuff that they don't need us for. So, and I'm like, well, okay. And I noticed it went down about an hour before that. And I said, okay, what did you guys do? Well, we didn't do anything. I'm like, okay, you had to have done something. That, because everything was down. They had, I think, like a dozen switches in 4 or 5 different areas. And I said, you had to have done something. And because I know better. And he goes, well, we did add a switch. Well, that's something changed. And he's just like, oh, okay. You look at it that way? I was like, yes, I do. So he was like, okay, what do we got to do? I'm like, okay, where did the switch come from? Well, it came from our lab. Okay. Were you doing a lot of testing with that? And he goes, yeah, we were. Okay. Um, so unfortunately for me, the only thing they had was a basic internet at that point. So I had them go to that switch and I had them unplug it because their network was down hard at that point. What ended up happening was that new switch had a higher revision number, but had the same Vtp domain. So what it did is it actually propagated a bunch of VLANs that did not exist inside the production network that did exist in the lab for all their testing. Well, that basically broke their entire layer 2 environment. Everything was broken because every switch received that update. Every switch was considered to be a client except for the core switch, which was in transparent mode. So it was the only one that was still operational. But because of the fact that it was operational, none of the other switches could reach it. That was the only device that I could reach, which also in turn was their edge router. So I was like, okay. So I took a look at it, and I knew almost immediately what the problem was based off of the symptoms that had been given to me. And I told him what he needed to do, and he consoled into the new switch, and he blew away the old configuration. Fortunately for him, he still had old configuration from a server. The drawback, that server was located in a colo location an hour and a half away from him. He didn't have anything local to his site. So fortunately for him, one of my help desk guys, and I'm really happy I got guys like that, were able to connect into their network, to their colo from our network, and then they were able to get that information to him via his email on his phone, and then he was able to copy that to his laptop and copy that to his through a console connection to each one of the switches. So it did take a little bit of time to get it working, but eventually it did get working. And it was just a matter of just copying and pasting in the configuration again, and it brought the switches back up. But he had to walk around to all the switches and console into them to fix it. So that is why a lot of companies don't like doing that. And I had never actually seen that prior to that happening. And the reason for that is because most companies like running in transparent mode. Transparent mode acts like a lot like server does, where you can do adds, deletes, and edits as you see fit. The drawback to this guy, which also could be its power, is that it doesn't listen to VTP updates. So if it receives a VTP update in, it doesn't do anything with it. It just passes it on. So it says, well, I see it coming in. I'm not going to do anything with it, but it pass it on. That allows you a lot of flexibility. That's why a lot of companies like running transparent mode. Now, if you understand what VTP can do to your network, it is pretty powerful if you understand how to work it. Now, I was able to go in and tweak his network a little bit to prevent that from happening, but it was one of those things where he was like, well, we needed more port density. I was like, oh, I get that, man. I get that. But before you go throwing a new network device into the network, call me before you do it. And he's like, okay, why? I said, because I'm going to probably pick your brain for a couple of minutes and ask you where this device came from. Was it brand new from, because I'll jump in, I'll take a couple of minutes, I'll WebEx in, and I will configure it for you. I got no problem taking 10, 15 minutes out of my day and, taking an existing configuration you've already got going, tweak it a little bit, drop it on your new switch, and away you go. This way here, it's done right the first time. And he really liked that idea. This way here he wouldn't have any issues down the road. So that's what we did. So the new switch that it was actually came from the lab that he just popped into the network and took down his entire network with, we reconfigured it, and it was set up as a client switch, and we added it to the domain, and everything was happy. The users were able to come up, they had internet access, everything was good to go. But that's a situation that can break your network. So typically the way you would do this is you're going to configure the ports as, the switches as the specific the mode based on what your needs are. So what I'm going to do is I'm going to make this guy here a server. I'm going to make this guy here a server. I'm going to make this guy transparent. I'm going to make this guy a client. Just so you guys can see a little bit of a variation and how this would actually work. Now I'm going to have to configure the VLANs on the for the client mode switches, so you guys can see how that works, because I won't be able to create a VLAN on the switch. I'll have to do it elsewhere, and it'll have to propagate to the switch. So what I'm also going to do is I'm going to set up a password of, I'm going to say Cisco with a question mark, and that will be our password. Now, to do this, it's actually really simple. Go ahead and pull up Secure CRT, and I'm going to go ahead and start on switch 1. I'm going to log in. There we go. Go to global config. I'm going to type in this case, it's going to be Vtp Domain is going to be CCNA SPNGN1. That's this course name. So that's going to be what we set the VTP to. I'm going to set the VTP password to be Cisco with the question mark. So, okay, but you might be like, well, wait a minute, how do you do that? Because the question mark is context-sensitive help. Well, in order to place a unique character that is not alphanumeric, so not a number or a letter, it's a special character, you press Control V and then the password, and then it takes it as such. So now the password is Cisco with a question mark. So remember, use Control plus V will allow you to use a special character. If I wanted to make the VTP password Cisco Bang or Cisco that, I could. But notice how, well, in this case here, and if you're using context-sensitive help, it's got to be the Control V with the question mark. But in this case, Cisco Bang will work, or Cisco exclamation point. So we have that. So now I can go to switch 2. You notice how all these other switches popped up. They're like, oh, we have something new happened here. We do a show Vtp status. You're going to see a couple things. You're going to see that the domain name is CCNA SPNGN1. And you're going to see that the my MD5 digest is goofy. Let's go over here to switch 1 and take a look at it. Do show VTP status 0EB 0A0 037 0CF. Definitely not correct. So if we did a show VTP password, we don't have one. So we have to go to here to global config and type in VTP mode is going to be server, which it is by default, and VTP password is going to be Cisco Bang. Okay, now that changed, and now we type in do show VTP status. Now we've got 6 configured VLANs, configuration revision number is that, and now if you look at 0 by EB, 0 by A0, that's what you want to see. Now we're going to go over here to switch 3, and we're going to say enable config T. I'm going to type in the do show VTP status. You'll see that we are CCNA SPNGN1, and our MD5 digest is incorrect. So we're going to say VTP password is going to be Cisco Bang. Okay, that changes that over. Do show VTP status. Now this changes over, but we need to change our operating mode as well. So VTP mode is transparent. Now we're in transparent mode. Notice the configuration revision changes to 0. We're not going to listen to any updates that come in. If we type in do show VLAN brief, we only have one VLAN information, one VLAN here configured. But that's what we learned from switch 1. If we go to switch 4 and do this, show VTP status, you'll see that we're SPNGN1 and our MD5 digest. So we're going to go to global config. We're typing VTP mode is client. Our VTP password is Cisco Bang. Now it says we have an MD5 digest checksum mismatch received on that port. That's okay though. We just changed that. So do show VTP status. And we have a checksum mismatch. That's okay though. This will change the moment we get a new update. What we have to do here on switch 3, if we type in do show VLAN brief, we're only learning one VLAN in, which is VLAN 13. So in order to fix this, we have to go back to switch 3, because if we typed in VLAN 12, for instance, is going to say VTP VLAN configuration not allowed on when device is in client mode. So we can't configure a VLAN. We have to go to switch 3 and type in VLAN is going to be 24. Name is going to be R2 to R4. And VLAN is going to be, I believe I said 212. Yeah, 212. Go ahead and clear the screen off real quick. It's going to be VLAN 212. Name is going to be R2 underscore Xr2. Do that. Do show VLAN brief. Now we've got them situated. I'm going to exit out of here. That's going to take care of applying that configuration. So now that's been applied. Let's go over here and switch up to here. Do show Vtp status. You're going to see that we have do show VLAN brief. This guy do show Vtp password. Cisco bang. Let's go to switch 3, or sorry, switch 1, and do show Vtp status. Let's see here, exit. There it goes. And go to switch 4. And they should propagate here momentarily. Do show Vtp status. All right. Well, oh, that's. Oh, I'm sorry. That's that's switch 4 to switch 2. Okay, so switch 2. Do show Vtp status. Do show Vtp pass. Let's get the right password. Let me configure the VLANs here. So we'll say do show VLAN brief. VLAN 311. Name is going to be R3 underscore to Xr1. Exit out. And let's see, switch 4 should have fixed it now. There it goes. Do show VLAN, or do show, yeah, VLAN brief. So we have that guy configured. It's not learning the other VLAN information for whatever reason. And I'm not sure why that's not happening. Because it should be, and it's not. So we need to come in here and let me do a VTP, or do a VLAN 100 name test. Exit. Do show VLAN brief. And go to switch 4, and that's really weird. I'm not sure why that's not doing anything. Because it should be receiving the updates. Do show Vtp status. It's learning them in, that's for sure. Interesting. Very interesting. I wonder, can we do a debug? I haven't tried that on viral yet. A VTP doesn't detect that. Spanning tree. Oh, it does do. Okay, it supports spanning tree, but it doesn't support VTP. Interesting. Okay, so show VLAN brief. Yeah, see, it's not learning those other VLANs. It needs to be able to learn. If we type in, it should learn 24 and 12, and it's not. Let me do this. Let me go to interface range gig 1/3, gig 2/0. Let me shut those interfaces down. This will cause switch 4 to do a request to these to switch 3 into switch 2. So no shot. If that doesn't fix it, I'll just go ahead and flip it over manually. But this is one of the reasons why sometimes it doesn't work properly. So if I do on switch 4, if I do yeah, see, it's just not taking it. And I'm not sure why. It may be it may not be truly supported in viral. I'm really not sure. config T, I'm going to type its VTP mode is going to be server, and I'm going to say that I need do show VLAN brief, and do show Vtp status. See, the first thing that I want to make sure the domain name has got a match in order for updates to be received in, and that's going to be the big thing. So configure VLAN 24, name is going to be R2 to R4, and VLAN 212, I believe is what it was. Yes, VLAN 212, name is going to be R2 to Xr2, and end out show VLAN brief. All right, so there we go. So now they're set. VTP mode is client. All right, so change that over and show VLAN brief. All right, so they're still there. Now I can apply ports to VLAN still. I just can't create a VLAN, edit, or delete one. So what I'm going to do now is, in order to make this work correctly, I need to go down here to I need to go to switch 1 and make sure that the ports that are necessary to be where they need to be are there. So do show VLAN brief. Okay, so he's got all the VLANs that he needs. Even though he's got VLANs that he doesn't technically need, he still has them. But that's okay for this. Up to this point, we're okay. So what I'm going to do is on switch 1, I know that VLAN 13 needs to be on gig 0/1 pointing to R1. I need to place gig 0/2 inside of VLAN 311. So I'm going to type in interface gig 0/2, type in switch port access VLAN 311. That's where that needs to be. And switch port mode is access. Do show VLAN brief. So that's been placed in that VLAN. So now I got to go over here to switch 2. Let me go ahead and do a do write. So I'm going to save the configuration in case we had the power cycle or some other catastrophic failure happens. I'm going to go to switch 2. I'm going to type in do show VLAN brief. So all the VLANs are propagated at this point, and then we're going to go to interface gig 0/3. Switch port access is VLAN 311. Switch port mode is access, and interface gig 0/2 is going to be switch port access VLAN 13. Switch port mode is access. Do show VLAN brief. So awesome, we have got the ports correctly identified and where they need to be. Let's do the same thing on switch 3 and switch 4. So in switch 3, we're going to do a show VLAN brief. We're going to go to config T, no VLAN 100, do show VLAN brief. There we go. We're actually missing a VLAN, which is VLAN 311, but we don't really necessarily need to worry about that one because of the fact of we don't have anything to do with that one. But you'll see that the transparent mode part of this guy is actually working as expected, because if we don't need to know about it, we're not going to know about it. And in this case here, because it's transparent, we don't care about any VLANs unless the ones we manually configure. So we're going to say interface gig 0/1 is going to be switch port access is going to be VLAN 212, and when switch port mode is access, and interface gig 0/3 is going to be switch port access VLAN 24. Switch port mode is access. Okay, so do show VLAN brief. All right, so we have those guys applied. We're going to type in do write, and then go to switch 4, show VLAN brief. We're going to say global config. We're going to say interface gig 0/2, and that's going to be VLAN 24. So we're going to say switch port access VLAN 24. Switch port mode is access. Interface gig 0/1. I'm sorry, 3. Switch port access VLAN 212. Switch port mode is access. Do show VLAN brief. So those ports should be in the correct VLANs. Now, the true test here is to log into these switches and verify connectivity. So what we're going to do is we're going to cover up the switches. I'm going to go to router 1. and ping 10.1.13.3. I can ping that all day. Now I need to go to router 3 and I need to say ping 10.1.13.1. Okay, so I need to do a show IP interface brief. What I'm going to do is I'm going to rename this IP right here on gig0/1. So I'm going to go to global config, interface gig0/1. IP address is going to be 10.3.11.3/24. Do right. And I'm going to go to Xr1. And I know you guys haven't seen Xr1 configuration yet, but it's actually really simple to do. I'm going to go to global config. Let's type in interface. In this case, it's going to be we did switch on router 3. We did port 1. So I'm going to go to Xr1 and it's going to be interface gig0/1. This command is not authorized. Do show IP interface brief. Beg your pardon? This command is not authorized. Oh, I know why. Cisco. There we go. So I was I forgot that when you're dealing with viral XR with iOS XR, Cisco is what you have to use to log in. When you download a viral, the virtual machine, and run it as a standalone VM inside of ESXi outside of viral, then you can use whatever hostname you or username and password combination you want. So I type in do show IP interface brief. We have that IP address. So we're going to type an IP address of 10.3.11.11/24. Now if we type in do show IP interface brief, you'll notice that that hasn't changed. Well, actually, it's shut down. So, actually, no, it hasn't changed the IP address. So what we have to do is we have to type in, if we do a show configuration, this is the candidate configuration. So this is a little bit different with XR where you have to commit the change. So I'll commit that change, do show IP interface brief. And now 10.3.11.11 is up. So I'm going to type in do ping 10.3.11.3 and I can ping it all day long. That's what you want to see. So that means R3 can talk to XR1. So now I'm going to go do the same thing with XR2 to R2 and 2 to 4. So starting off on XR2, we're going to Cisco show IP interface brief. And if you're wondering why I couldn't do the configuration with me logging in as Rob, and that's because of the fact that the username Rob has absolutely no privileges allowed to it at all. It can't configure anything because the setup is incorrect. I have to go in there and do that. I'll show you guys how to do that later on. So we're going to come in here and go to global config, interface gig0/1 and type an IP address of 10.2.12.12 and commit. So we're going to go over to R2, make sure that the configuration is correct before I go any further. Show IP interface brief. Config T interface gig0/2 is IP address of 10.2.12.2. And I'm going to say do ping 10.2.12.12. There we go, that works. I'm also going to try to ping interface gig0/1. Is that what I was just under? I type an IP address of 10.2.4.2. And I'm going to do right, that's configuration. And I'm going to go to switch router 4 and take a look at this as well. Enable config T, host name is R4. Do show IP interface brief. Interface gig0/2. The IP address of 10.2.4.4/24. No, shut that interface. Give that a second to come up. do ping 10.2.4.2, give the second for ARP to go out, and there I can ping it. That means when I go into routing in the upcoming section, I should be able to form dynamic adjacencies between these routing protocols, between these routers, and move into all that other good stuff. So what does all this mean at the end of the day when it comes to layer 2 stuff? What that means for you and I is that the configuration options that we have set up here are working as expected. So we have connectivity where we need to have connectivity. Now, what I haven't shown you guys, and I'm going to be saving that for when we talk about inter-VLAN routing when we get into CCNA Part 2, but normally you would be doing everything on the physical interface, because on a physical interface of a router or a switch or an access point, or sorry, as a firewall, when you're dealing with a switch, as in this case what we're doing here, the physical interface of a router or a firewall is going to treat all traffic on the physical interface as VLAN 1. Okay. On a switch, it's still technically it's not going to be encapsulated with anything as it's leaving the switch. So it's going to come in, it's going to be the native VLAN of 1. It's actually going to be untagged because when you're dealing with trunking and things like that, the native VLAN is going to be the untagged VLAN, and the native VLAN is always untagged. So VLAN 1 is the native VLAN. VLAN 1 is going to show up as 0. It's going to be an all zeros VLAN ID in the VLAN tag. So that means the native VLAN. Now, when you're traffic coming in on gig 0/1 on R1 is going to be leaving out on VLAN 1. The switch actually doesn't know that that's VLAN 1 traffic. It just knows that it's got a port in VLAN 13, or sorry, port in VLAN 13 here. It's got a trunk port that's able to forward that traffic on. So traffic is going to come in here, is going to be in VLAN 13 here, be tagged across this link here, be received in here, placed in VLAN 13, and go up to router 3. But router 3 is going to receive it as VLAN 1 traffic. Now don't freak out. It's not some sort of magic voodoo going on behind the scenes. It's just a simple fact that on the physical interface of a router and a firewall, it treats it as VLAN 1. The moment you go in there and you configure this port here or this port here as a trunk port, and you're sending more than one VLAN up to the router or the firewall to do your inter-VLAN routing, then the you have to get into sub-interfaces, because the physical interface will only respond to VLAN 1 traffic. You'd have to create a sub-interface that's going to be listening for the tag of whatever VLAN you've created it for to listen for, and that traffic is going to come in. Now, if that sounds a little confusing to you, I know, and I understand that. It'll make a lot more sense when we get into CCNA Part 2, but the general idea works like this. When I have VLAN, if I have non-VLAN 1 traffic coming in, let's say I have VLAN 10, 20, and 30 coming in, I'm going to create what they call a sub-interface. So I'm going to type in gig 0/1.10. .10 is going to be meaning that I'm going to be listening for VLAN 10 traffic, but that .10 doesn't actually map to the VLAN ID. You have to type in encapsulation VLAN and then the ID you want it to listen for. I usually create the sub-interface to map to the VLAN ID that I'm listening for, so that it's easy to identify what type of traffic that's going to be. Then I come in here, I type in encapsulation VLAN 10, and then I give it a subnet, say 10.1.10.0/24 or something like that. That'd be how I go about doing that. So in a situation like that, that's going to be how that would come into play. Now that's what they call router on a stick, where the router is going to be listening for traffic coming in on multiple VLANs. It's actually going to do what they call hairpinning. Traffic is going to come in on this interface and go back out on that interface. But because of the fact that it's technically not coming in on the same interface as it's leaving, it's technically not split horizon. We'll talk about split horizon later. The idea here is if traffic is coming in on VLAN 10 but is destined for VLAN 20, it's technically coming in on one sub-interface and leaving on another. So it's not a, you're not doing same interface routing. So just so you guys are aware of how that would work from a high-level overview. So that's pretty much everything I can think of that you need to worry about for right now. We'll get into more of the complicated design stuff and more advanced configuration in CCNA Part 2, but for right now, we're in pretty good shape. So we'll take a look at network optimizations in the next video, in the next section, as we get into spanning tree and ether channels and flex links and things like that as we move forward.